Welcome to the hidden layer, where we decode the future of artificial intelligence.
Okay, let's just jump right in with a pretty wild idea. We're all used to thinking of AI as an app, right? It's a tool that we run. But a groundbreaking new paper from Meta AI is asking a much bigger question. So, over the next 5 minutes, we're going to unpack their concept of neural computers, we'll break down this radical new vision for computing, and most importantly, I'm going to give you a powerful contract from this paper, a mental model that you, as an engineer, can use today to build more verifiable and way less buggy AI agents. You are definitely going to want to stick around for that. First things first, let's talk about the problem. I mean, for all their incredible power, today's AI agents are still basically just guests. They're running on a computer architecture that hasn't really changed in decades.
And this slide right here really gets to the heart of it. The classical computer on the left, it's got all these separate, rigid modules for compute, memory, and I/O. Our amazing AI models, they're just another layer kind of tacked on top of this massive kind of brittle stack.
So the solution in the paper isn't to just add another layer. Nope. It's to collapse the whole stack into something completely new. They're proposing a new kind of machine, the neural computer, or NC for short.
Okay, I know the formal definition sounds a little dense, but the crucial point is this. The whole idea is to make the model itself the computer. It unifies everything, memory, computation, the interface you see, into a single dynamic learned state.
So let me put that in simpler terms. Imagine a single neural network that has learned how a computer feels and works so perfectly that it can just dream up the screen frame by frame. It responds to your clicks, your keyboard, as if it were a real operating system. This all sounds a little bit like science fiction, right? I get it, but the researchers at Meta AI didn't just stop at the theory, they actually went ahead and built prototypes to see if this is even possible. And well, check this out. They created 2 of these NCs. One is called CLIGen, and it learned to operate a command line terminal. The other, GUIWorld, learned to use a full graphical desktop, mouse, keyboard, the whole shebang.
Now, are they perfect? Not yet. But what's amazing is that these models learned the fundamental physics of a user interface. You know, how a terminal scrolls, how a menu pops up when you click, just by watching videos of people using them.
Okay, so this is a super cool glimpse into the future. But what about that promise I made at the start? Let's bring this down to earth and talk about how this can help you, as an engineer, build better systems today. The paper actually gives us an incredibly useful mental model for exactly that. It's called the run/update contract. And the idea is really simple, but it is so powerful. For an AI agent to be reliable, its behavior shouldn't just silently change while it's working. Any change to its core skills has to be an explicit, intentional update. So here's how you can actually apply this thinking. First, when you're designing your systems, separate running a task from updating the agent's skills. They're 2 different things. Second, make those updates deliberate acts, not just random side effects. And third, create clear audit trails so you can actually track and verify why your agent's behavior changes over time.
Adopting this mindset really helps tackle a huge problem with complex agents, that unpredictable, sometimes baffling behavioral drift we've all seen. This contract helps you build systems that you can actually understand and, trust.
So, if that's the practical takeaway for today, where is all this heading in the long run? Well, the paper outlines this incredibly ambitious final goal.
They call it the completely neural computer, or CNC, and this is the endgame. It's the mature, general-purpose version of the NC that's as powerful and flexible as a classical computer, but it's built on this entirely new learned foundation.
You can see this represents a true paradigm shift in how we even think about computing. We'd move from writing explicit, often brittle lines of code to instead configuring a robust, fluid machine by optimizing its internal state to achieve a goal. And that brings us to this quote, right from the paper, that I think just sums it all up perfectly. This isn't just about building another AI tool, it's a potential rethinking of the machine itself, right from the ground up. It's a massive vision, for sure, with huge challenges ahead, but it leaves us with a really provocative question to think about. What would it mean to compute not with logic, but with learning? Thanks for joining us on The Hidden Layer.